Hello and Assalamu alaikum. Ladies and gentlemen, this channel is purely dedicated to research. If you are watching this video, please do subscribe to my channel to stay updated with latest research and what's going on in the research world. Good evening, ladies and gentlemen. Today, we are going to talk about sample size calculation for synopsis and research studies. I am Dr. Ammar Anwar, and I'm a neurosurgeon by profession and chief editor of Pakistan Journal and Surgery and Medicine by passion. In this talk, we will be discussing about calculating the sample size, what's the correct way of sample size calculation. Secondly, we will be discussing briefly about how to submit your synopsis in time, the tips and tricks, and what is data collection necessary for synopsis. And last but not least, in this talk, we will be discussing about rationale for synopsis, but this talk will be primarily focusing on sample size calculation because a lot of people have asked me about this and no, and not many people know how to calculate sample size. It's very easy. So now we will be starting with discussion about calculation of sample size. So the first thing that we should know is what is sample size. Sample size is denoted by the letter small n, and it refers to the number of participants or observations that are included in your study. This number is usually represented by n. The calculation of an adequate sample size thus becomes crucial in any clinical study and is the process by which we calculate the optimum number of participants required to be able to arrive at ethically and scientifically valid results. The next thing that we will be discussing is precision of estimate and power of study. The size of sample influences two statistical properties that are the precision of our estimates and the power of our study. I have discussed about the sample power and few other terminologies in my talk last week about the basics of research methodology, and this can be seen here. Now the question comes that why we need a sample size. N is the number of participants that are needed to detect a clinically relevant treatment effect. This is the first thing that we should all be aware about. The main aim of a sample size calculation is to determine the number of participants that are needed to detect a clinically relevant treatment effect. For example, if you're conducting a study on whole population, you will have to determine a number of participants that can be representative of that whole population. The sample size shouldn't be too small or too large. It should be adequate. And today we will be discussing how you can calculate an adequate sample size. If you have any questions, please raise hand and I'll be happy to answer them. Now coming to the next part, what are the attributes of a good sample? The attributes good sample should have few characteristics, which are every individual in the chosen population should have an equal chance to be included in the sample. Ideally, the choice of one participant should not affect the chance of an other section and others selection, and this is called randomization. The third characteristic of a good sample is it should have acceptable level of significance. We will be discussing this term in upcoming slides. It should be equal. It should add to the power of the study. The sample should have the expected effect size, and if by effect you mean the sample should have the expected disease or the expected thing that you are studying, and it should be representative of underlying event rate in the population, that is the disease that we are studying. So now moving on to the next part of our presentation, that is some important terminologies that you should be familiar when doing sample size calculation. Uh, the first of all, we should understand what population is. The reach or total number of people to whom you want to apply the data. This is called your population. The size of your population will depend on your resources, budget, and survey method. There are three basic types of population in a study that can be included. The first one is sample. This refers to the individual with the disease or condition of interest who will be included in this study. The second part of population is accessible. This is the population that includes all the individuals with the disease or the condition of interest who are accessible for the study investigators. So the first is sample that you have to study. The second part is accessible, all those people who have the disease and can be included. And the third part is target. This refers to all the individual with the disease or the condition of interest on whom the study findings will be generalized and applied. So the study population comes down to the target population, and this is the thing that you should always keep in mind. The next thing in sample size calculation is probability or percentage. This is basically the percentage of people you expect to respond to your survey or campaign. And the third thing is confidence. This means that how confident you need to be that your data is accurate. This is usually expressed as percentage, and the typical value is 95% or 0.95. This means that you are 95% confident of your data's accuracy. The next thing is margin of error or confidence interval. This is the amount of sway or potential error that you will accept. It is a plus minus value that you see in media polls. The smaller the percentage for your sample size, and the better will be your confidence interval. For example, if 45% of your survey respondents choose a particular answer and you have a 5% margin of error, then you can assume that 40 to 50% of the entire population will choose the same answer. I hope that you are clear on this point. If there are any
हाँ, एक मिनट
ambiguities till
राजू.
now, please do ask.
हाँ हाँ, एक मिनट राजू.
Uh, there is another thing that we are going to now do sample size calculation for proportion. First of all, we should know what proportion. First of all, we should be aware about certain terminologies, and after that, we will be proceeding to sample size calculation. What do you mean by proportion? Proportion is a part of population that possesses a particular property. For example, uh, a group of people that have hepatitis C or hepatitis B, that will be your proportion, and this is within a specified margin of error. The second thing is level of significance. This is usually denoted by the p-value, and this is the level of significance. And prior to starting a study, we set acceptable value for this p. We hypothetically suggest that our study will have a significance value of 0.005. This means that we are willing to accept the detection of difference of 5 out of 100 times when actually no difference exists, to rule out false positive results. The third thing is confidence interval. Confidence interval, I'll be elaborating this in the next slide, but for now, just keep 68, 95, and 99.7% rules. I'll be elaborating this on upcoming slide. The next thing is design effect for complex or sample surveys. I know that these terms are boring, but you need to have a basic concept of these before we can proceed with doing actual calculation. A design effect is an adjustment made to find a survey sample size. Uh, this may be due to a sampling method, for example, cluster sampling or stratified sampling, which results in larger sample size. The def tells you that magnitude of these increases and its effect on your study. So now we will be discussing about the basics of confidence interval and what this is. This is basically what you are seeing on your screens is called as empirical rule, and empirical rule also referred as 3 sigma rule or 68, 95, 99.7% rule is a statistical rule which states that a normal distribution, which is almost always observed in data, will fall within 3 standard deviations. Here you can see on the screen there are 3 standard deviations. The first one is 68.27, the second one is 98.45%, and the third one is 99.73%. Most of our study, they fall between 95.45%. In particular, the empirical rule predicts that 68% of the observations fall within first 5 standard deviations. That is 68.27% of your all observations are within the first 5 standard deviations. 95% within the first 2 standard deviations. That 95% of your subjects will have the results that are within the first 2 standard deviations, and 99% of the subjects may have results that are within the first standard deviation if your sample size is accurate. So now we are just moving. I hope that can you see on your now we are going to proceed with the sample size calculation, and I'll be showing you how you can calculate sample size. I use OpenEpi for sample size calculator, and all you have to do is Google OpenEpi and just write it. This is how you will be. I hope that you can see this on your screens. Can you see OpenEpi on your screens? Anyone?
Yes, it is visible.
Okay, that is good to know. So now we will be here. This is the OpenAPI menu, and you can see a lot of things. But now you have to concentrate on this. Sample size calculation is very easy. The first thing that I have discussed with you is sample size calculation of proportion. I have discussed all the terminologies with you. So now we will be proceeding with calculation of sample size. So here you enter population size. Uh, if your population size is large, leave it at 1 million, but you can input the accurate sample size. For example, if we want to if we want to see a particular frequency of a particular disease in Pakistan, I'll input the population of Pakistan, that is 220 million, and you can input, actually I always forget that, but let's put it at 1 million. This is 1 million, and let's say that we are studying it in a big city of Pakistan. Anticipated frequency of the disease, you can come up with this frequency value from literature. There is always published literature out there, so just go and find what is the prevalence of the disease and input that value here. Confidence interval is as zero point 0.5. For example, if I input the prevalence of that disease at 30%, let's say, and that is for random sample, because I'll be selecting sample randomly, and it is not consecutive sampling, it is randomized, so leave it at 1. Now calculate the sample size. Population with 95% confidence interval comes at 323. This is for your sorry, I was doing it for proportion. Now for proportion, this is here population size, anticipated frequency at 30, and confidence interval 5. Let's calculate the sample size. So this is the 323. As you can see that this 323 is your sample size. It is very easy to calculate. All you need to do is to input this thing. You can find the frequency of the disease by studies. Just go find and input, and then once you have found the proper sample size, proper prevalence, you can find the sample size with the help of, this is for proportion. If you want to study the proportion of a disease in a particular population. So if you have any questions till now, please do ask. This presentation will be available on ResearchGate, and you can also download it later on. So we are now moving on with the next part of, excuse me, so first I told you how to calculate sample size for proportion. Now we are moving on to calculation of sample size for unmatched case control. Uh, Unmatched case control studies, basically these are those type of studies that you usually use in your synopsis for UHS. These include quasi experimental studies and non-randomized studies. So this is very important, if very important for those who are submitting synopsis, and you should please concentrate on this part, because this is how you calculate the study. The first thing that you should know is two-sided confidence interval. The two-sided confidence interval is basically used for testing a hypothesis that has a yes or no answer. There is a null hypothesis that you use, and I have already elaborated on null hypothesis and alternate hypothesis in basics of research methodology presentation, that is available in the AUPSP group and on the YouTube channel. So this is basically for testing the null or alternate hypothesis. The second term that you should be familiar about is power. Power is the chance of detecting a disease or validating your hypothesis. It is usually considered to be at 80%. The third thing that you should know is ratio. Ratio is basically the number of cases to control, because you are doing an unmatched case control study, or if you are doing a non-randomized study, this is what you leave. If you are recruiting equal cases and equal controls, then this means that there is 1-to-1 ratio, but you have not randomized them like in quasi experimental studies, so leave the ratio at 1. The next thing is odds ratio. Or there is odds ratio is basically a statistic that quantifies the strength of association between two events A and B. The odds ratio is defined as ratio of odds of A in the presence of B and the odds of A in the absence of B or equivalently, and other way around. For example, if viral hepatitis, hepatitis B causes liver cirrhosis, and this is your hypothesis that viral hepatitis causes liver cirrhosis. So the odds of having liver cirrhosis in patients with viral hepatitis, the odds ratio will be 1, because all the patients of viral hepatitis will have liver cirrhosis. So this will be the odds ratio. This is the simplest way that I can explain. If you have any queries at this point, please do ask. And there is one more thing, that the odds ratio is symmetric in the two events and there is no causal direction implied. A positive odds ratio does not establishes that B causes A or A causes B, but this shows that this disease can be present in the can be caused by one of these. So if you have any queries till now, please do ask. And the next thing is percentage of cases with exposure. This means that how many people who have got the disease, who were exposed to the virus have got the disease. For example, the virus was 20 people were exposed to the virus, and out of 20, 5 people got the disease. So that means that 5 people out of 20, and that means that that is roughly 25% of cases with the exposure. I hope that I'm very clear till this point, because now we will be calculating sample size. As I have told you that as I have told you that I use uh, the OpenEpi for sample size calculation. So I'll be taking you there. And so this is OpenEpi, and now we will proceed to here. In the unmatched, this is the unmatched case control you can see here, and I'll be inputting these values. For example, two-sided confidence interval, I keep it at 95%. I keep power at 80%. Ratio of cases to control, I keep at 1. But if in your sampling you have recruited, for example, if you have 50 cases and you have 50 controls and 100 cases, then the ratio of cases to control will become 0.5. Percent of control was exposed, we have discussed it at 25%, so I'll keep 25%. And percent of cases with exposure, you have to input one of the values and the other one will show up. So if the percent of cases with exposure, if you keep it at 70%, 70% cases have exposure, odds ratio is 7, and this is how you will calculate the sample size. With there are 3 studies, and you can always mention one of them. Casley shows that the sample size of cases should be 20, controls should be 20, and total sample size should be 40. Fliss shows that it should be 19, 19, and 38, and Fliss with CC shows that this should be 46. These are 3 basically different sample size. So these are the values that we have inputted. That percent of controls is exposed is 25. For example, this means that every fourth control has got disease, or 5 out of 20 controls who were exposed to viral hepatitis have got liver cirrhosis. And percent of cases with exposure, this means that in your cases group, the viral hepatitis, the cirrhosis is present in 70% of the cases. So this will how you will calculate. This is very, very easy. All you need to do is to have a basic knowledge of the terms, and you can do sample size calculation on your own. So now we will be moving on to the next part, that is sample size calculation for cross-sectional studies, cohort, and randomized controlled trials. This is important if you are, I have already discussed two-sided confidence interval, power of study, and the ratio. The next thing that you should need is percent of unexpected with outcome. Odds ratio, we have discussed it in the past slides. And now we will be moving on to calculate the sample size, because people have asked me how this is done, and this is easier than you think. All it takes is 5 minutes and some basic knowledge about the terms. So we are back to the OpenEpi, and here we will be go to cohort and RCT. As you can see that values are same, confidence interval 95, power is 80%, unexposed to exposed 1%, and now input just one of the ratio. For example, if we input odds ratio of 7, so this will show up. This is the same odds ratio that I have inputted in the previous study. So now just calculate the sample size. This is the sample size for your case control, for your randomized control trial. This is not for, sorry, I have selected the wrong option. Here you will just enter 1 and I'll enter the odds ratio of 7. And let's calculate the sample size for cohort RCT. This is the sample size for cohort and RCT with all the three studies, which means that you need 88 sample size. Cohort cross-sectional studies, you need 88 subjects to study, and if you want to study it in randomized control trial, then just 44 cases, and there will be 44 controls. That's it. This is the basics about sample size calculation. It is not that difficult. All you need to know is some basic knowledge about terminologies and how to calculate them. And I hope that I'm clear till this point. If there are any queries, please do ask, because after this, we'll be moving on to uh, next presentation. Next part of the presentation. The common sample size calculators that are available are WHO calculator, can be accessed online. OpenEpi calculator that I have just shown you. I use OpenEpi because it is easy to use and it is the best calculator out there in my experience. So I'll recommend that either use WHO calculator, that is a bit difficult. OpenEpi is a lot easier, and if you have watched this presentation till end, then you will be able to use OpenEpi calculator. I'll recommend that all of you do a few calculations in your free time, and if you have any queries, you can reach out to me. Now, there are a lot of people have asked me that how they should submit their synopsis in time. So here is a timeline for what you should do. When you have started your residency, uh, during the first month, just go to your supervisor and tell him or her that you need a synopsis topic. The supervisor will give you synopsis topic, and once you have got the topic, go to the synopsis repository of UHS. You can access the synopsis repository of UHS here. I'll just show you, because people have asked me that how we can see that whether the study has been done in the past or not, and just Google it. UHS synopsis repository, and you will find this research repository. In the research repository, you will find all of the synopses that have been approved by the UHS in your discipline, and you can see that PhD, MS, MD, I'll go with MS, and I'll show you that the synopses that have been approved. Okay, so I'll show you my synopsis, and this is my synopsis that has been approved. Comparison of minimally invasive lumbar hysterectomy. You can check the topic here. You should always check the topic here before starting work on your synopsis. Now that you have got your synopsis, and now that you are in month 1, you have got a synopsis topic. You should get your synopsis topic within the 30 days. It is very, very easy. In this, I'll be taking a brief break for Azan, and we'll be continuing after the Azan. Dr. Usman, you have raised a hand. Can you please ask your question? I would love to answer that. Dr. Usman,
सर क्रॉस सेक्शनल स्टडी के बारे में दोबारा सैंपल साइज कैलकुलेशन के बारे में बता दें
ठीक है,
थैंक
उस
यू
पे I'll get back to this in a while, and first let me proceed with the second month. Second month में आप लोगों ने क्या करना है? In the second month, you have to write the synopsis. My colleague Dr. Usman has given a very beautiful talk on writing a synopsis. The links are in our group, and you can go through that. But if you have any queries, I can give a talk on that as well. And the third, in the month 3, submit your synopsis to UH. It takes only 3 months for you to submit your synopsis. Only 3 months, and by the third month, you should all have
ਹਾਂਜੀ
your UHs.
ਹਾਲੇ ਰਹਿੰਦਾ
I'll be I'll be going back to answer Dr. Usman's questions, and sample size calculation for cross-sectional studies. Dr. Usman, I'll be showing you again how you can calculate the sample size using uh, the sample size here, and this is basically once you go to OpenEpi, just go here and select cohort RCT. In the OpenEpi menu, first go to OpenEpi website. Once you are there, select the OpenEpi, select the sample size here, you will find it here. And in the cohort RCT, all you have to do is to input the results. Keep the confidence interval at 95%, keep the power at 80%. If the unexposed to exposed in your sample is ratio 1, for example, the people who have got the disease, who were exposed to viral hepatitis and had got liver cirrhosis are equal to, their number is equal to those who were not exposed to viral hepatitis but have got liver cirrhosis somehow. Their number is 1, and all you have to do is input one of the values here. If you keep the odds ratio at 1, so this is how the rest will fill up, and you can calculate the sample size. This is your sample size. But you can change the variables, and you can always come up with the new. For example, if you are keeping the ratio of exposed to unexposed at 0.7, okay, so and keep it at 10, make it 10, and let's see how this. Keep the odds ratio at percent of exposure outcome. Just let's put odds ratio of 2, and let's calculate the sample size with this. This is your sample size. This is just an example. This is not how you will proceed with your study. For your study, you have to understand the parameters that I have already explained. If this is Dr. Osman is this is basic of how to calculate sample size. If you need further details, please go through the presentation, and do listen to my talk when it's on YouTube, because I have to move on due to shortage of time. So now the next question that people have asked me, how to do data collection for synopsis. The first thing that you need to understand is what synopsis is. Synopsis is basically a brief summary of the major points of a subject. In medical research, it means an outline of your project. You write synopsis for research articles, for getting ethical approval from institutional review boards. You write synopsis for your thesis or dissertations, and this is basically an outline. So you don't need any kind of data collection. You just need to say that I'll do these, and these steps. Another thing that was, another point that was raised yesterday was how synopsis should be written. Synopsis should be either written in future tense or in the past tense. The next thing is rationale, and what is rationale? Although UHS has removed the portion of rationale from the synopsis, but rationale is the articulation of reasons for conducting your research. In your rationale, you will tell the university that why this synopsis is important and why you should be conducting this synopsis, this study for your thesis. The rationale should have the following. It should have bibliographic citation of the independent population and of the intended population. It should have a brief summary of the work and its educational significance. It should have purpose of using the work and how it will be used. It should elaborate that what is the importance of your work, and it should highlight the potential problems with the work and how these can be handled. Rationale is very, very important when you are writing a synopsis. And the last but not least, the thing that people asked yesterday was synopsis submission guidelines. The synopsis submission guidelines are available on the website of UHS, and you can get them from there. It is very, very easy, and I hope that this gives you a brief understanding of the sample size calculation and brief outline of synopsis and how you should submit it hurriedly and quickly. So if there are any questions, please do ask. Yes, Dr. Osman, I can see your hand. Any questions from the audience? This video will be available on my YouTube channel, and if you there are a few other videos as well. The presentation will be available on my ResearchGate profile, and I'll be giving next talk is about referencing. So if you want to know how to do bibliographic citations of synopsis, and thesis, you should attend my talk. And thank you so much for being a very receptive audience. And I'm going to conclude this meeting now. If you have any questions or queries, you can always reach me on this email address, and I'll be glad to answer them. So thank you so very much, and Allah Hafiz.